All right. Let me see here. It's good to see you guys. Last day of class. So I've been going through and making sure the grades are all in, and um, if I see any anomalies, I'll email you. But otherwise, I want you to look through your grades and make sure I haven't missed something, made a mistake. Maybe I told you I'd give you credit for something or I didn't, or I said I would accept something late and I took points off. Anything that is anomalous, anything that is different from what I said, I want you to tell me so that we can get it right and we can get you the best grade you deserve. And in general, though, I do want to say you guys have done amazing work in this class. You've all been working really hard, and I know this course is a lot of work. And um, encourage you to think back on what you knew 4 months ago and what you know now, right? In terms of being able to build actual applications. And so, congratulations. Um, you all have come a long way. And, looking over your grades today, your grades are actually quite good. And so, um, I'm not particularly worried at all. But I want you to review that because I don't want somebody to get, an A minus instead of an A because something got overlooked. Okay, so let me share my screen. That. Okay, so first, let me go over this. The final complete project, I say that it's due, I think, on Friday, but you really need to have it in before the presentation on Monday, the 14th. I think that's what the 14th is. Is that right? Yeah. And so basically what's going to happen is I want you to turn in your final presentations before that so that we can have it all set up. You're going to come in, we're going to try to keep things moving along. Each group is going to get to present for about a half an hour, and then we're going to take questions and talk about it, and then we'll move on to the next group. Again, you should be prepared. There's an evaluation form that everybody will be filling out on everybody else. And that will partly determine your grade on this final presentation. So basically, the things that you have yet to do is obviously to turn in the final project, which is just your GitHub, any documentation you have, and a link to the web page. You have to turn in your presentation slides, and then you have to do your presentation. That's all part of the same thing. And then you have to write up your personal statement. And then again, I want you to turn in an evaluation form for each of the other teams. And so you'll just click on here and you can fill out as many of these as you want. You pick the team, and then you assess the quality of their presentation. Okay. All right. So the last thing we're talking about today is, of course, refactoring. And keep calm and refactor your code. What is refactoring, right? Right here we see this image of this windmill that's not very good, and we see this really nice one. Clearly, sometimes our code can get pretty bad, right? And refactoring is really taking a bad program and hopefully turning it into a good program. So why do we do it? What are the benefits of doing refactoring? that you guys discovered or you guys are thinking about?
Well, its main job is to reduce complexity, right?
Okay, right. So that's a big deal, right? I mean, complexity kills. I mean, two-word statement that's really true. Complexity kills. When systems get too complicated, they just break down. And so reducing complexity is huge. They break down mainly because we don't understand them. We just don't understand them. What else? What are other reasons for doing refactoring? Well, look at these windmills here. Which one of those windmills do you think is going to produce more energy? Right? It turns out that when we refactor, we oftentimes make our code more efficient, right? We don't change what it does. We just make it work better, right? It maybe doesn't use as much memory. Maybe it runs faster. Maybe it doesn't break down as much, right? Maybe it's easier to read. Maybe when we go to change it, it's easier to change. When we want to add a new feature, it's easier to add a new feature, right? So there's actually lots of reasons for doing refactoring, because we're fixing up our code and we're making it better, we're making it more repairable, we're making it faster, we're making it use less memory, we're making us able to change it, we're making it break down less. So is it desirable? Well, clearly from all the things that we've said so far, it seems to be pretty desirable, right? Now, I found this cartoon, it's kind of interesting. The life of a software engineer, clean slate, solid foundations. This time I will build things the right way. Much later, oh no, I've done it again, haven't I? Right? I think we all hit that, right? We're trying really hard to write good code, but then we have to change something, and then we have to change something else, and we have to move something, and after a while, our code doesn't look so good anymore, right? This happens to everybody because things evolve. And so we end up with this mess. So this whole concept of the waterfall is a myth. Requirements, we write requirements, we do a design, we do coding, and then we do maintenance, right? That doesn't work that way. Reality is more like this, right? We work on requirements and we do some design, and we got to go back and do some more requirements, and we do some design, then we do some coding, but then we have to go back and do some redesign, then we do some coding, we realize we need some other requirements, and the thing just keeps cycling around. And what this does is this is like shuffling the deck of your code, right? Your code just deteriorates over time, literally deteriorates, right? Code doesn't wear out, it deteriorates as we maintain it. So software evolves. So software evolution is like a biological evolution in many ways, that some mutations are beneficial, but frankly, many are not, right? And so the cardinal rule of software evolution: refactoring is a change made to the internal structure of the software to make it easier to understand and cheaper to modify without changing its observable behavior, right? So the whole point of refactoring is not to change what the program does, but to make it work better on the inside. So here's a little one aspect of refactoring, right? That's kind of a cycle. So right here on this red, we identify some code that maybe isn't where it belongs. Maybe it's repeated over and over again. And so we look at that code and we say, can we pull that out and make it better? So we write a unit test. We say we do this, we write a unit test because we have to figure out, what does this code do? We have to understand what it does. And the best thing to understand what it does is to come up with a way of testing it. Then we create a module that will replace that code, move that code into a function, test the code with the unit test, and then replace the code with this new function call, right? This is one type of refactoring. We identify some code that really belongs isolated in a nice cohesive function. Now, I'm not going to go through all this, but the whole point is we can look at our code and we can identify problems, and then we come up with strategies for removing those problems, right? Here we see we have a long method. Here we have two different classes that have similar but slightly different interfaces. That's confusing. We have these two chunks of code are identical, right? And so we're looking for things in the code that could be improved. Code smell. Have you ever smelled your code? You might have written some duplicate code without looking at the existing code, or you may have written some longer functions or methods, large classes, have too many parameters, non-intuitive variable names, code placement is poor. All these bad practices lead to a deeper problem, which is known of as code smell, right? And frankly, it can be embarrassing. I mean, there's been times when I've written code just to get something done, and then later some other people have to look at it, and I'm like, oh my God, did I write that? I didn't want anybody to look at that, right? Just like I don't want anybody maybe to see inside my desk drawer because it's messy, right? But this is even worse. So 7 reasons why code refactoring is important. To keep your code clean, right? Which is, like Rand says, reducing complexity. To improve the performance of the application. Oftentimes when we refactor, we're improving efficiency, right? We're noticing that we're doing things in ways that are not particularly efficient with respect to runtime or memory utilization. You save time and money in the future. Well, why do you save time and money in the future if you refactor?
There's probably less cost in the future to fix the code because code wears out.
Yeah. Right. So spend a little bit now, save a lot later, right? It's kind of like if your roof is bad and you just keep patching it and don't actually fix it, maybe you get leaks here and there, and after a while, you have to rip the entire roof off your house and replace it instead of just put new shingles on, right? You're actually wasting money by not spending money. And so it's actually worth the time or effort. It actually saves you. Now, to reduce technical debt, I mean. Now think about this, essentially, if you have bad code, it's like you're going into debt fixing it all the time, right? If you have bad code, instead of working on new things, instead of developing new products, all your time is spent fixing a bad piece of code. And it's like going into debt. And this happens, right? I can tell you this happens. Sometimes you have code that it's like, yeah, we got to fix the code again. Yep, it's broken again. Now, sometimes your code is outdated. And refactoring can fix that. Now, what do we mean by that? Well, the world of computer science is constantly changing. We're learning new things. New libraries are coming out. New subsystems are coming out. And, we may just not be up to date, and we may not be taking advantage of important new available resources. For example, let's say we're using a really outdated version of a database, and it does not even support it anymore, right? Or it doesn't provide good security, or it has errors in it because it's old and they were never found, and now they moved on to new versions that fix those errors, right? Sometimes it's time to go in and say, hey, there's a new way to do this that's so much better. You know, it actually makes bugs easier to be found if code is nicely refactored, and you can improve your overall system design. So there's lots of reasons to refactor, and I'm going to kind of go through these quickly. But code duplication is huge. If you see you're writing the same 4 lines of code 6 times, you probably need to refactor that code out, right? If a routine is really long, it's certainly not cohesive, and it's probably a time to think about, well, how can I break this up into components that are cohesive? If a loop is too long or too deeply nested structures are hard to understand, right? If you're more than about 3 or 4 levels deep in a nesting, you've gone too far, and you probably need to break it up and repackage it and reconfigure it. Obviously, if a code has poor cohesion, remember, cohesion means it has lots of connections with other pieces of code. Pieces of code that have lots of interconnections are more complicated and more likely to break. A class does not provide a consistent level of abstraction. Sometimes we have a class and we say, oh, I need a new function there, and we add one. Oh, I need another new method, and we add one. And we might not add methods right, or somebody later might come along and kind of hack the code, and they add something that is at a different level of abstraction. For example, if we have a I don't know, an inventory, a class for inventory items, and we notice in there is a method to detach link list. Well, linking lists do not have anything to do with inventory items. That's probably a lower level of abstraction, and it should be hidden. Parameter list is too long. Anytime you have to do parallel modifications, it's a problem. In other words, it's like whenever I add something over here, I have to also add something over there, right? Somehow you didn't hide things correctly, right? If you didn't hide things so that when you change something in one place, you have to change it in one or more other places, there's not good abstraction going on. Related data items that are used together are not organized into classes, right? If you just have a bunch of data that goes together, but you didn't put it in a class, bad news. A routine that uses more features of another class than it does of its own class, right? This is actually a lack of cohesion, right? If something depends on too much on something else, you probably didn't slice it right. Primitive data type is overloaded. You probably don't know what that means, and so I don't know if I'll talk about it, but that's not something you see very often. Class doesn't do very much. If a class hardly does anything, maybe it's not a good class. A chain of routines passes tramp data. What does this mean? Tramp data. That's a pretty cool illusion, right? Tramp data. What do you think that is? No idea? Well, the idea of tramp data is like, I suppose, the idea of, the old idea of the guy who sneaks onto a railroad car to get a free ride, right? And the idea is you're passing data through routines to other routines that the intermediate routines don't care anything about that data. They just, it's like, well, I got to get it over there somehow. And so through this call chain, you know, A needs to send some information to B, but it does it by sending it to C, D, and F, and then finally to B, right? It's like none of those intermediate things need to know about this data. They shouldn't have access to this data. The person who looks at that routine shouldn't see this data because it doesn't have anything to do with it. That's tramp data. I don't know why I did it twice. There we go. The middleman object isn't doing anything. One class is overly intimate with another, right? So if classes are digging around inside each other, maybe, again, you didn't slice it up right. That's too much cohesion. If things just have poor names. If data members are public, generally we want to keep things private. If a subclass uses only a small percentage of its parents' routines, I don't know why this thing makes it go through it so many times. Comments are used to explain difficult code. If you need too many comments, maybe you didn't write clean code. Global variables are always something to cause worry. A routine uses setup code before a routine call or takedown call code after, right? You have to do a whole bunch of stuff, then call a routine, and then you do a bunch of stuff afterwards. Probably you didn't package things right. Probably that stuff needs to be done a different way, right? The move in the world is to what we call zero configuration code. In other words, you just call something and it works. It's smart enough to work without you having to set things up before you call it. A counter contains code. A program contains code that seems like it might be needed someday, right? Putting extra stuff in there for the future may not be a good idea because it just adds complexity. Let me jump through all this. There's all sorts of types of refactorings, and I'm going to jump through to here though. Now here's the interesting thing. Small changes tend to be more error prone than larger changes. Huh, why is that? Any idea?
Because people seem to think that like a small change, they don't need to be as careful.
Okay, so they might
like
just not be
larger
careful enough, right? Yeah, think about what might be going on here. You go in there and say, I can just make this one little tweak. I see this line, right? You may not have thought through the context of that change, right? It's quick and dirty, with an emphasis on dirty. So, you know, when do you refactor? Sometimes it's a good idea to refactor when you add a routine or a class or when you fix a defect. Sometimes if you have modules that seem to be getting a lot of errors, it's time to go in and say, I think I'm going to do a rewrite on that. Sometimes you target things that, you know, that thing is really complicated. Let me simplify it, right? I've had situations like that in professional work where I've had really complicated routine and it just kept spending all my time, you know, trying to debug it. And then I thought it was working and then it would get another bug and find another bug. And finally I just rewrote the whole thing from scratch and everything worked great, right? In fact, one of the things to think about is that sometimes writing the bad version is a process of discovery. And once you actually figure out what you want, then it's time to go back and write it correctly, right? It's not a bad thing to write a bad routine. It's a bad thing to write a bad routine and say, well, I guess I'm stuck with it. That's a bad thing, right? We all are going to write bad code simply because we don't know what we're doing the first time around. So in a maintenance environment, improve everything you touch, right? It's kind of the idea of let's go ahead and clean up while we're in here. So one thing we can think about is that basically what our goal should be, we have the messy real world that we want to interface with. And what we want to do is we're going to have messy code to interface with the messy real world. But let's try to have as much as possible of the code neat and tidy. So in other words, let's say we have a routine that sort of looks like this. Here's the real world mess, and here's the messy code, and there's very few routines that are nice and tidy. Well, if we can sort of push this up so that the veneer of interface to the untidy world is as minimal as possible. I don't know. Okay, there we go. Yes, that must have been the end. Oh yeah. Okay. So what I want to do is, I guess I hid this slide. Let's unhide it. There we go. That's what happened. Okay, so let's take 10 minutes here. What I want to do is put each of you in your perspective groups. And I want you to talk and then come back to the larger group and tell us about, look at your code and tell us what you found where you think a refactoring might be useful. I'm not asking you to do the refactoring. I'm asking you to think about the refactoring. Okay, so start thinking about that now while I get ready to pop you in your groups. It's going to take me a few seconds to do this. Okay. All right, so breakout room. So I'm going to make 4 breakout rooms, and then I will manually put people in. Okay, so here we go. It's going to take just a second. Lucas, Drive. Why am I not keen? Okay. Okay, there you go. So I'll bring us back in about 10 minutes. Hi, how you doing?
Hi, Professor. I'm doing pretty good.
Okay.
I finished like few functions, and I post all of this to my GitHub, and I can link my GitHub like in the chat if you want.
Okay, well, before we do that, did you get my email?
Not really. Like.
Okay, so it turns out that we never did the final review of project 2, which is how I graded it. I was supposed to meet with everybody. And so we can't do that now, but we need to do that this week, okay?
Okay, cool. What about, okay, cool. I'll like reply your email and sign up. Do you have office hour left like in this week?
Yeah, I'll have office hours this week, yeah.
Yeah, then I'll come like maybe in Friday, your office hour. Would that be okay?
I think so. Let me see. My office hour on Friday is at 8 to 10 in the morning. Let me see here. I just have to check one thing real quick here because I have to take my daughter to the doctor, and I want to see what time that is. That's not what I wanted to do. Hang on here. Yeah, here we go. I think we might have to push it a little bit later. Like, can you come at 2 on Friday?
Yes, of course.
Yeah, let's try that. I hope I'll be back by then. I think I will be.
Mhm.
Okay. So, all right. So you should be thinking, I'm going to let you think about your refactoring and look at your code, and you're on your own team, of course, but I don't mean to take time from you thinking about your refactoring.
Mm-hmm.
Good. 2-minute break.
How you guys doing? You finding some stuff?
Yeah.
Yeah,
Okay,
found,
good.
we found a lot of places that we can do a refactoring.
Good, good. Yeah, that's what I want you to think about. Yeah, whether you do it or not is up to you. But right now, we're just trying to discover it. Okay, just checking in.
Yeah.
How are you guys doing?
Good.
We're doing well. We're talking about our process results, how it's a bit how we could have